Hello everyone, welcome to our presentation. I am Sandareka Vikramanayaka from National University of Singapore. In this paper, we conduct a review of existing methods to develop deep neural networks with intrinsic interpretability. We give a more focus on convolutional neural network as most of the work are dedicated to make DNNs interpretable. The aim is to understand the current progress towards fully interpretable DNNs that can cater to different interpretation requirements. Through our survey, we identified that we can categorize existing interpretable DNNs into three categories based on how they make the model interpretable. One of the most popular approach is integrating attention to DNNs. This is common in natural language processing, domain-specific models, and fine-grained classification tasks. These models aim to expose the parts of an input the model focuses on making its decision. The second category develops DNNs that can make decisions based on prototypes. These prototypes can be obtained from expert knowledge or learned automatically. These models present set of prototypes as the explanations for their model decisions. Finally, some models regularize the features learned to introduce interpretability to DNNs. For example, interpretable CNN learns disentangled features and comprehensible CNN learns features correspond to word phrases. Next, we present our observations about existing work. We observe that most of the interpretable DNNs make decisions based on a linear aggregation of the learned interpretable features. The difference lies in how the interpretable features are defined and how such features are learned. For example, ProtopNet uses prototypes and CCNN uses features that correspond to word phrases. Further, many of these interpretable models can only explain the prediction for an individual data point, whereas ProtopNet and CCNN can additionally provide the concepts important for predicting a certain class. For example, ProtopNet can show the prototypes that contribute to the highest number of correct classifications of a class. Another observation is that features learned by some of the interpretable DNNs may not correspond to concepts consistent with human perception. The visualizations of these features indicate that they are activated to either a partial region of a concept or for a region of multiple concepts. We also notice inconsistencies in evaluation studies of existing work. While interpretable DNNs should be evaluated for both predictive performance and interpretability, some of the current work evaluate only one of those aspects. Finally, we propose potential research directions derived from our survey. We believe that interpretable DNNs should cater to different users who may want to understand the model from different perspectives. For example, one might be interested in understanding the rationale behind a specific model decision, while another might be keen to understand counterfactuals, meaning what changes in the input would change the model prediction to a predefined output. None of the existing interpretable DNNs provide all these explanations. Hence, investigating ways to provide explanations from multiple perspectives is a promising research direction. Another direction is to develop interpretable DNNs that can provide semantic explanations. We see that most explanations provided by current interpretable DNNs are visual explanations, either in the form of saliency map or prototypes. However, visual explanations may be ambiguous. The ability to explain DNN decisions using semantic concepts is more useful. Finally, creating a unified criterion to evaluate interpretability of learned features is another promising research direction. Existing work have introduced various metrics evaluating different aspects of learned features. We believe that not having a widely agreed upon notion of an interpretable feature has led to numerous metrics. Given that feature interpretability is an essence of a fully interpretable DNN, having a unified objective metric to evaluate feature interpretability would enable researchers to benchmark different inherently interpretable DNNs. Thank you.